Hi, welcome to 11.4, Equations Quadratic in Form. So the hope is by the end of this, you all will be able to solve equations that are quadratic in form. So these are equations that aren't necessarily quadratics when they begin, but they have the same form and we can use the same methods to solve them. So let's review the quadratic solving methods that we've done so far. First off, there's solving by factoring. Solving by factoring is where you set the equation equal to 0. You factor that standard form of the quadratic expression, and then you set each factor equal to 0 and solve. That method, it's quick. It's really nice, especially if you're good at factoring. That is a really quick, easy, wonderful method, but it only works if it's factorable, and not everything is factorable. The next one we had was the square root method. The square root method was where you had something squared equals a number, and then you took the square root of both sides and had your two answers, the plus or the minus. And that one was really quick. It was really easy, wasn't it? But of course it only works if it's in that format of something squared equals a number. The next method we got to is completing the square, which definitely took longer. But it was nice and algebraic. It was very procedural. We could go through that process. And the nice thing is that it always works no matter what, okay? And the last one is the quadratic formula. The quadratic formula, it wasn't as quick as factoring, but not as long as completing the square, somewhere medium in length. It also always works, which is really nice. But the only thing is that you do have to have that formula memorized, okay? And from here on out, you can use whichever method you'd like. So let's go through some of these examples. So the first example I have for you, you'll notice that's not a quadratic. I know. But we're going to get a quadratic as we go through the process of solving it. So we've got 4 over x minus 1 plus 9 equals negative 7 over x. Okay. If you need a quick review over solving rational equations like this one, the first thing that you should do is multiply by the least common denominator. So my denominators are x minus 1, that's one factor, and x, that's a different thing. So the least common denominator for this one, it includes both. We need an x minus 1, and we need the x from here, okay? So when I multiply everything by the LCD, let me show you what happens. So I'm just going to write it by every term. I'm going to multiply by x and x minus 1, multiply that by the first term. I'm going to multiply that next term, the 9. I'm going to do the same thing. I'm going to do 9 times x minus 1 and times x. In that last term, the negative 7 over x, I'm going to do the same thing. I'm going to multiply it by x minus 1, and I'm going to multiply it by x. I'm just writing it by all three terms because we're multiplying both sides of our equation, which means we're multiplying all of the terms on both sides of the equation by the same thing. So take it one at a time. The first term, you'll notice that the x minus 1s are going to divide out. You're just going to have x times 4, which is 4x. In the second term, nothing divides out, so we just need to multiply everything together, okay? So let's see. 9 times x is 9x, and 9x times x is 9x squared. Then I've got 9 times negative 1, which would be negative 9. And negative 9 times x is negative 9x. And that is everything multiplied together on that one. For my third term, the x's are going to divide out. So then we just have negative 7 times x minus 1. I think we can do that. Negative 7 times x is negative 7x. Negative 7 times negative 1 is a positive 7. So after multiplying by that LCD, you notice that we have an equation that has no denominators, which is a lot easier to solve. The other thing I'm noticing here is that I have an x squared term, which means I do have a quadratic. So let's go ahead and get everything on the same side. I'm going to go ahead and add 7x to both sides and subtract 7 from both sides. And let's put these in order. I'll have the 9x squared first, since it has the highest exponent. All my x's. All right, so 4x plus 7x is 11x. 11x minus 9x would be a positive 2x. Then we have this minus 7 that doesn't have any like terms. And now we're equal to 0, and now we're in standard form. From here, it's your pick which method you like to use. You can pick factoring, you can pick completing the square, you can pick the quadratic formula. This one's not in that square root form though, so probably not using that one right now. So it's your pick. It does factor if you're interested in factoring. So let me show you that one real quick. To get 9x squared, your options are either 9 and 1 or 3 and 3. Let's try 9x and 1x. To get the 7, it's 7 and 1. It's nice and prime, but it's just a matter of like, where does it go, you know? So here's a 7 and a 1. To get a negative 7, one of them is negative and one of them is positive, okay? And then once you make those guesses, so that the first times first gives you the first term, the last times the last gives you the last term, you just check to see if you did the right combination. The outer product, 9x times 1 is 9x. The inner product, negative 7 times x is negative 7x. And 9x minus 7x is the 2x, which is my middle term. I picked the right combination. If I did not get that middle term, I would try something else. You could switch the 7 and the 1. You could try 3 and 3. There's some options there. But this is the correct factoring for this one. From here, we'll set each factor equal to 0, and we'll solve. So there's my two factors. 9x minus 7 equals 0, x plus 1 equals 0. To solve the first one, I would add 7 and divide by 9, so x would be positive 7/9. For the second equation, I would just subtract 1 from both sides, so x would be negative 1. Okay, you should check the answers, at least make sure they work with your denominators, and they both do. So those are our two answers for this one. All right, next up is a nice little word problem. It says, in 1 3/4 hours, Mark rows his boat 5 miles upriver and comes back. The speed of the current is 3 miles per hour. How fast does Mark row? All right, so let's kind of figure out what all we have here. In that 1 3/4 hours, he goes upriver and comes back. So basically the time to go upriver plus the time to go back. It's kind of labeling here. Those times added together equals that total time of 1 3/4 hours. Okay, that's what that tells me. Let's see, the distance upriver is 5 miles, and I would assume it's the same coming back. So the distance to go up equals the distance to come back, which equals 5 miles. Okay, I'm just writing out what I have from my problem right here. The speed of the current is 3 miles per hour, so current speed is 3 miles per hour. How fast does Mark row? So we would like to solve for Mark's boat's speed. So I'm just going to call that B for boat. Okay, and that's what we're solving for. So this is me going through that paragraph of a problem and writing out what I have so that then I can come up with an equation to solve it. Okay. With distances, these are speeds or rates and times. I'm probably looking at the equation distance equals rate times time to kind of guide me along the way. If I notice this equation up here, it had t's in it. So I'm going to take this and just solve it for t. I'm going to divide both sides by r and say d over r equals t, like that. And so what I'm going to do is I'm going to substitute for the time up as the distance up, which we know is 5 miles, over the rate. If he's going upstream, that means the current is working against him. It's slowing him down. So his speed would be his boat's speed minus the current, which is 3. That's going to be his rate as he goes upriver. The time to come back, I'm going to do the same thing. I'm going to do d over r to be for my t. So the distance to come back was also 5 miles. The rate, when he's coming back, now the current's helping him. He's going along with the current, so it's going to speed him up a bit. So that's going to be his boat speed plus 3. And then that equals our time, 1 3/4 hours, which let's go ahead and convert that to an improper fraction so we can do our arithmetic a bit easier. 4 times 1 is 4, plus 3 is 7. So 1 3/4 is the same thing as 7/4 hours. And now I have one equation using all of our information that can solve for our variable. We yet again have a rational equation. So I'm going to multiply by that least common denominator, which means I'm going to multiply by b minus 3, b plus 3, and 4. So it's going to be a fun time, all right? So that's what I'm going to do. So I'm going to multiply both sides of my equation by the same thing. I'm going to multiply by b minus 3, b plus 3, and 4. I'm going to multiply all terms on both sides of my equation by that LCD. All right, so let's talk about what happens one term at a time. First term, the b minus 3's are going to divide out. So I'm going to have 5 times 4, which would be 20, times b plus 3, which I'll multiply out in a minute. Next term, the b plus 3's are going to divide out. So now I've got 5 times 4, which is 20, times b minus 3. On the other side of my equation, the 4's will divide out. So now I have 7 times b minus 3 times b plus 3. Well, let's make our lives a little easier and multiply those together. B times b is b squared. Then I have a 3b and a negative 3b, which is going to cancel out. And then negative 3 times positive 3 is negative 9. All right. Life's getting better, I think. Let's go ahead and simplify some more. Let's do the rest of our multiplying. 20 times b is 20b. 20 times 3 is 60. 20 times b is still 20b. And 20 times 3 is still 60. All right. On the other side, 7 times b squared is 7b squared. And 7 times 9 is 63. And at this point, you can see we're going to have a quadratic. We have a b squared right there. So let's see. The 60s are going to cancel out over here. 20b and 20b makes 40b. So if I want to get that on the other side, I'm going to subtract 40b from both sides of my equation. So then it equals 0. So now I'll have it in standard form, 7b squared minus 40b minus 63 equals 0. This one does factor pretty nicely if you are up for it or if you're quick at factoring. 7b times b is 7b squared. To get the negative 63, I've got some options. You know, you could do 7 times 9, you could do 3 times 21, or you could do 1 times 63, okay? Those are your options for getting 63. So if you try 7 times 9, you're not going to put the 7 with the 7b because that would give you a least common denominator, right? Or a GCF in there. So that's not a good place to put the 7. Let's put the 7 on the other side. Let's put the 9 here. And see, one of them needs to be negative. So let's try this. That would give us negative 49b. We'll just do it over here. Negative 49b. This will give us a positive 9b. And that adds to equal negative 40b, which is exactly what we're looking for. Okay? So now we have those. Let me keep going on the next sheet of paper here. You can see what we're doing. Here we go. So then we'll set each factor to equal 0 and solve. So I'm going to have 7b plus 9 equals 0. And I'm going to have b minus 7 equals 0. From the first one, I would subtract 9 and divide by 7. So I would have b equals negative 9/7. From the second one, I would add 7 to both sides, so b equals 7. You always need to, with word problems especially, go back to the context of the problem. Does it make sense to have a negative value for the speed of Mark's boat? No, it doesn't, because that would mean that he was going backwards. And he apparently makes the trip. So he's not going backwards. That doesn't make sense. Okay, but 7 miles an hour, that does make sense. That's a positive value, and it's bigger than the current, which is good. So 7 miles per hour is our answer for this one. All right, we're going to continue example 3 on the next video.